Hello everyone, this is Denver Doroha back at it again with another basic calculus video. So in today's video we're going to tackle the other trigonometric functions that we haven't yet tackled in the first basic differential rules video. These are the tangent, secant, cosecant, and the cotangent. So if you have remembered in our basic differential rules video, we've already tackled the derivative of sine, which is the cosine x. Sine x is cosine x, that is the derivative, while the derivative of cosine x is equal to negative sine x. So now we're going to tackle the remaining four. So without further ado, let's get right into it. So for the first trigonometric function that we're going to tackle, it is the tangent. So the derivative of tangent x is equal to secant squared x. So let's try and give an example. So I have already made an example, an incomplete example of this. So in the example, we're going to find the derivative of 1210x. So we're going to first separate the constant from the trigonometric function. So that is going to be 12 times the derivative of tangent x. So now we're going to find it, which is this one. So now let's just write the derivative of 12 tan x is going to be equal to 12 times this one, 12 times secant squared x, and that is the final answer. By the way, we're only going to have 2 examples per trigonometric function. So now let's go to the second example for the tangent. Just going to be it's going to be the derivative of 2x squared tangent x. Wait. Again, the derivative of 2x squared tangent x. So in this equation, in this function, there is 2 terms. So we're going to be using the product rule. So our first term, our f of x, is going to be 2x squared. And by using the constant multiple rule, the f prime of x is going to be equal to 2 times 2x raised to 2 minus 1, and perform the integrated operations. That's going to be 4x. No need to copy the 1. Next up, our g of x is going to be equal to tangent x, and by the trigonometric function rule, we're going to be using secant squared x as its derivative. So now by the product rule, f prime times g plus f times g prime. So the derivative of 2x squared tangent x is going to be equal to f prime, that is 4x, times g, that is tangent x, plus f, that is 2x squared, times gx, which is secant x squared, and perform the operations. That is going to be 4x times tan x, that is 4x tangent x, plus 2x squared times secant x squared, that is going to 2x squared times secant squared x. And that is going to be the final answer for this example. So moving on to the next one, which is going to be the secant. So the derivative of secant x is going to be equal to secant x tangent x. So let's so secant x tangent x. So now let's give an example. So number 3, let's try the derivative of 3 secant x. So how we're going to solve this? We're going to use the constant multiple rule. So yeah, we're going to separate the constant, which is 3, multiplied to the derivative of secant x. Derivative of secant x. That's going to be 3 times the derivative of secant x is secant x tangent x. So our final answer for the derivative of 3 secant x is 3 secant x tangent x. So let's try another one, a little bit harder one. Let's try and use 4x times secant x. Now again, we're going to use the power rule, which states that f prime times g plus f times g prime. So we're going to first identify our first term, which is 4x. So f of x is equal to 4x. So by using the constant multiple rule, that is going to be f prime of x is equal to 4 times 1x times raised to 1 minus 1. F prime of x is going to be equal to 4, since all of this just equates to 1. Now our second function, g of x, is equal to secant x. So by using, by the rule, the derivative of secant x is going to be secant x tangent x. So now let's substitute all of these given to the formula. The derivative of 4x secant x is equal to f prime, this one, 4 times g, which is secant x, plus f 4x times g prime, which is secant x tangent x. So perform the operation, that is 4 secant x plus 4x secant x tangent x. So it's going to be our final answer for this example. So moving on to the third one, the cosecant one. So the derivative of cosecant x is going to be equal to negative cosecant x cotangent x. So let's wrap this up really quick because my cell phone is low battery right now, so it doesn't charge when I'm filming a video. So yeah. Number 5 example, f of x is equal to 10 cosecant x. So again, by using the constant multiple rule, the derivative of 10 secant x is, separate the two, 10 times the derivative of secant x by, now we're going to use the derivative of this, just substitute, times negative cosecant, this is not secant, this is cosecant, negative cosecant x tangent x, perform the operation. So the derivative of 10 cosecant x is going to be 10 negative 10 cosecant x tangent x. That's the final answer. So now let's move on to the next example. So let's try the derivative of 4x squared plus 3 cosecant x. So we're going to use the addition rule, which states that we're going to find the f prime of x and then the derivative of g of x. So yeah, so our first function is going to be 4x squared, and by using the constant multiple rule, f prime of x is going to be equal to 4. Move the 2 in the front, x raised to 2 minus 1. F prime of x is going to be equal to 4 times 2, 8x raised to 2 minus 1, that is 1, not necessary to write because the answer is going to be the same. So now the g of x is going to be 3 cosecant x, and this one is also going to be using the constant multiple rule. So that is 3 times the derivative of cosecant x. So the g prime of x is going to be equal to 3 times the derivative of cosecant x, which is negative cosecant x tangent x. Now perform the operation. G prime of x is equal to negative 3 cosecant x tangent x. Now perform the operation. So the derivative for 4x squared plus 3 cosecant x is going to be equal to f prime of x, 8x plus g prime of x, negative 3 cosecant x tangent x. So now we're going to distribute the addition sign to this. Just going to give us 8x minus 3 cosecant x tangent x. That's the final answer. So moving on to the last and final trigonometric function that we're going to tackle, which is going to be cotangent x. So the derivative of cotangent x is going to be negative cosecant squared x. So without further ado, let's get right into the examples once again. So number 7, let's say we're going to find the derivative of 4. No, we've used too much number 4. 5 naman. 5x cotangent x. So we're going to be using the product rule for this one, where it states that f prime times g plus f times g prime. So yeah, our first function is going to be equal to 5x. Now using the constant multiple rule, again f prime of x is going to be equal to 5 invisible 1, 1x raised to 1 minus 1. That leaves with f prime of x is equal to 5. Next up, g of x is going to be equal to cotangent x, and the derivative of cotangent x is just negative cosecant squared x. So g prime of x is equal to negative cosecant squared x. And I'm going to wrap this up really quick and rush it because I'm at 5%. Oh my gosh. So yeah, first copy the equation, the derivative of 5x cotangent x is equal to f prime, which is 5, times g, which is cotangent x, plus f, which is 5x, times g prime, which is negative cosecant squared x. So now we're going to perform the operations. Just going to 5 times cotangent x is just 5 cotangent x plus 5x times negative cosecant squared x, that is negative 5x cosecant squared x. Distribute the addition sign, or I mean the positive sign, that is going to leave us with 5 cotangent x minus 5x cosecant squared x. That is the final answer. So now we're going to move on with the last example for today's video, which is, which is going to be number 8, the derivative of, what did I do last time? Product. So this time let's use subtraction rule. 2x cubed minus 5 cotangent x. So the difference, sum and difference rule, we're going to find that derivative of the first term and subtract it to the derivative of the second term. So let's get right into it now. Rush. F of x is going to be equal to 2x cubed. Using the constant multiple rule, f prime of x is going to be equal to 2 times 3x raised to 3 minus 1. F prime of x is going to be equal to 2 times 3, 6x. 3 minus 1 is going to be 2. That's the first derivative. So the second derivative, g of x, is going to be equal to negative 5 cotangent x. So let's use the constant multiple rule also. G prime of x is going to be equal to negative 5 times the derivative of the second term, which is cotangent x. So g prime of x is equal to negative 5. The derivative of cotangent x is negative cosecant, is it right? Yeah, negative cosecant squared x. Negative cosecant squared x. So perform the operation. G prime of x is equal to negative times negative, that is positive 5 cosecant squared x. So now we're going to perform the, oh, it's not focused, I'm so sorry. So here it is. Here's the solution. Take a look at it. Now yeah, let's move on. All that's left to do is all that's left to do is perform the subtraction. Let's copy the equation. The derivative of 2x cubed minus 5 cotangent x is equal to f prime of x, which is 6x squared, minus g prime of x, or 5 cosecant squared x. And that is going to be our final answer. So yeah, thank you so much for listening, and till again next time, this has been Denver Droha. See ya. Peace. Bye bye.